Alright, so this is number 36 on page 257. I'm going to try to talk a little quicker because I've done this once already and it took 12 minutes, and YouTube has a time requirement, or a time max, I guess, constraint. So again, we'll find critical points, increasing, decreasing, max or min, inflection points, concavity, and reference points. So let's start off with the derivative. And let's clean that up a little bit. So that would be, so y prime is going to be 1 minus 4x over x squared plus 1. And let's set that equal to 0 and solve. If you move this 4x over x squared plus 1 term to the right hand side, you'll get 4x over x squared plus 1. Multiply both sides, you'll get x squared plus 1 equals 4x. And we're going to collect terms to one side and then use the quadratic formula. So we'll get a 4 plus or minus a 16 minus 12, that's not true, minus 4 times 1 over 2. This simplifies down to 4 plus or minus 12 over 2. And I'm actually going to keep on going from here. I like to avoid decimals, and you should too. You should really strive to reduce this as far as you can. It's good practice again for building your skills with algebra. So there are two numbers here, and we can estimate them quite well without a calculator. Root 3 is about 1.7. So this upper one is about 3.7, and this one is about 0.3, which means I can get I can graph these on a little number line, say 0, 1, 2, 3, 4. Right here, I can do 2 minus root 3, and over here, I can do 2 plus root 3. Now to find out if the function is increasing or decreasing, we'll use the derivative. So let's try number less than 2 minus root 3, and 0 is a good choice. Why is this zooming? I think we're already zoomed in. So y prime of 0, well, that equals 1 minus 0 over 1, okay, which is positive. So we'll have the function increasing through here. And then y prime of 1 works. That's 1 minus 4 over 2, which is negative. So the function's decreasing through here. Y prime of, let's say, 1,000. That might seem like a silly number, but I want to illustrate a point that this is 1 minus 4,000. 1,000 squared is 1,000,000. So that's 6 zeros plus 1. If you look at this term, you don't need to know the value of this term. Right? This term is less than 1. So the whole thing is greater than 0, sorry. It's positive. And so it's increasing after this point. Okay. That tells us that this is a max and this is a min. Okay, on to concavity stuff. So I need to start with the derivative and then go ahead and get the second derivative, which would be 0 minus, we'll do some quotient rule. So this would be 4x squared plus 1 minus 4x times 2x all over x squared plus 1 squared. And so if we clean this up, we'll get 4x squared plus 4 minus 8x squared all over x squared plus 1 squared. You notice that the denominator is always positive. So continuing to simplify, we're going to have a minus 4x squared plus 4 over x squared plus 1 squared distribute the minus sign, we'll have a 4x squared minus 4 over x squared plus 1 squared. Now, we set it equal to 0 to find inflection points, and you will notice two things. One, the bottom never equals 0, and the top equals 0 when x is plus or minus 1. These are inflection points, since the top can also be factored as 4x minus 1, x plus 1. Okay, so as x changes from less than 1 to more than 1, or less than minus 1 to more than minus 1, these will change sign. So they are inflection points. So I'll add those to our graph. Right, so there's minus 1, and that's one inflection point. And then here's the other one. So let's put our second derivative information up top. So looking at our second derivative, let's go ahead and try some numbers out. Again, the bottom is always positive. So if I try a number less than minus 1, say minus 10, I get 400 minus 4 over a positive number. That's positive. And so I'm concave up on that region. Down here, I could use 0, give me minus 4 over a positive number, which is negative. So it's concave down in between these. And then one more value, I can use y double prime of positive 10, which again gives me 400 minus 4 over a positive number, so it's positive. And so it's concave up through the remainder of the region. So now with all this information, we're ready to make a sketch. Takes a little time, but let's see what we can do. So let's also get a few reference points. If you look at the original function, if you plug in 0, you'll get 0. So it goes to the origin. That gives us something. Now, looking at this, we have it increasing, but there's a concavity change at minus 1. So it's concave up, increasing, and then it continues to increase, but it's concave down right through here until it gets to this next point, but still increasing. And then it changes concavity right after this local max, right? So it goes from increasing to decreasing, still concave down, and concavity changes to concave up for ever after, and goes from being a min here. So we've got concave up, concave down through here, and then concave up again. So at 0, it'll be crossing over here, and then we have this transition point where it goes from being concave up to down, and then from there we're going to have a max just right over here. That's going to be concave down through whatever this minimum is. Okay, see right there, and it stays concave down the rest of the time. Let's grab the calc and plug this in before I run out of time here. So this is x minus 2 ln of x squared plus 1. And so there we've got the picture. Again, a little hard to see everything given the zoom, but you can play with your window and get a better picture. But that's not too different from what we've got. Okay.